Okay, we're going to take a look at working with what are called quadratic equations. Now, a quadratic equation is always going to be in the following form. It is always going to be ax squared plus bx plus c. It will always look like that. Now, when we're dealing with a quadratic form, we want it written like that, and what we call that is going to be standard form. Everything that we do with it is always working in this form of ax squared plus bx plus c. We identify what a is, we identify what b is, we identify what c is. So that when we come to doing specific things and trying to solve things, we know where the a is, we know where the b is, we know where the c is. Now, we've been playing with this kind of stuff for a while now. You need to be able to convert things over into standard form. Now remember, again, your standard form is going to be the ax squared plus bx plus c. That's what we want to see. Now sometimes it'll be equal to 0, sometimes you'll have y on the other side, but this is what we want to aim for. So when I look at this one here, I've got y minus and I have this. I'm going to add 6 to both sides. So I'm going to get my y equals. So 6 is gone from this side. But when I write this down, I want to put it in the proper order. So the proper order means whatever is squared goes first. So I look at this and I see a minus and an x squared, so it's going to be minus x squared. Now you don't see an a there, do you? But what number could be there if we wanted to put one in? A 1. So now over here I've got 2x, it's positive, so we're going to put in plus 2x. Over here we got, the last thing is the plus 6, so we end up with plus 6. So this is what we would need to be having when we are told to put this into standard form. That's what it's going to look like. Questions on that? So let's take a look at b then. I need to put that into standard form. What I see here is I see a 2 and I see a parenthesis. Now normally you guys would just go, good, distributive property, away you go. Can't do that. The reason that you can't do that is sitting right here. That thing squared. If you go back to your order of operations, you have to do your exponents before you do the multiplication. So what we're going to end up having to do is write it out like this. It's going to be 2 multiplied by x minus 4. Well, the squared means that I have another x minus 4 plus 9. So when you write it out like this, now you've got FOIL that you have to do. So 2 is still going to stay out in front. X times x is x squared. X times negative 4 is minus 4x. Minus 4 times x is another minus 4x. Negative 4 times negative 4 is 16. Now, I still have the plus 9 out here. 2 is here. Add like terms. X squared minus 8x plus 16 plus 9. So far, have we done anything that's terribly difficult and painful? We know how to deal with the FOIL. FOILed it out. We know how to add like terms. Now the distributive property gets used with that 2. So that 2 gets to go here, here, and here. Doesn't go with the 9 because the 9 isn't in the parentheses. So now what we got it looking like is 2x squared minus 16x plus 32 plus 9. Yep, and then I got to add like terms again, so it's going to be 2x squared minus 16x plus 41. Now, mind you, we still have this f of x out here yet, but that you can just plug that, put that in at the end. You don't really have to go through and keep it in there. It's just extra writing that we don't need. So does that make sense? Questions? Ready for the next one? It only gets more fun from here. So, we have something that is called a parent function. Now, when we are dealing with math and looking at graphs, we can do all kinds of things with a graph. We can move it around, move it up, move it down, move it left, move it right. We can rotate it, we can twist it, spin it, we can do a great number of things with it. But it's always in one basic shape. A quadratic formula that we identify, or a quadratic equation that's in its parent state, so to speak, is just this. Mind you, A is 1, B is 0, and C is 0. When we graph it out, it is going to look like this. That's all it's going to be done, or be doing. It's called a parent function. So whenever I see a graph like this, I know exactly what kind of an equation it's going to be. I know that it has to be somewhere along the lines of ax squared plus bx plus c. Now, how do we figure out how to graph it? Plug it in. If I put negative 3, what's negative 3 squared? 9. What's negative 2 squared? What's negative 1 squared? 1. What's 0 squared? 0. 1 squared. 2 squared. 3 squared. 9. All we did is took these x's, put them in here, so we can do that. Now, you guys know how to graph coordinates, right? Negative 3, 9. Right there. Negative 2, 4. There. Negative 1, 1, right there. 0, 0. 1, 1. 2, 4. 3, and 9. It's all right there. It's just how it goes. Now, I'm going to take that one step further. The curve that we have here is a special name. It's called a parabola. Curves, okay? Bouncy ball mathematics, U-shape. When a ball bounces, that's exactly what it looks like. Just a curve. Now, you guys ever see these things called bowls? You put soup in them, cereal or whatever. It's got the same shape. It can be identified by a mathematical equation for its curve. Now, for the graph of that, the point 0, 0 is the vertex. So, whenever I have this equation, the vertex is always going to be 0, 0. Now, if the parabola is opening up, the vertex will be the lowest point. If a parabola is opening down, the vertex is the high point. Now, one of the things that we concern ourselves with, especially when we move up into upper levels of algebra, is this idea of a zero. Now, a zero is just simply where it crosses the x-axis. It has some rather interesting properties for that. We're able to use it to do specific things. So whenever you're asked to find a zero, this is what you got to do. I'll show you a few ways of dealing with this so it makes life a lot easier for you. Now, something that you should have in your little book. Okay? Vertex can always be found identifying this. So generally what we do is we write it out as follows. your vertex is going to be at negative b over 2a. Now remember, we're pulling this information from ax squared plus bx plus c. That's where I get my a's and b's and c's. Now, the rest of this means, or I should say that you end up doing this, comma, f of negative b over 2a. All that second part means is, hey, you plug it into whatever equation you got. You take the b, you take the 2a, put the numbers in, figure out what that is. Take that value, put it into the equation, and see what you get out. But this is what we need to use to find the vertex. So I'll give you a moment or so here to get that. All right. So here we go. I want to graph this quadratic function. Now I've got this identified here, the x squared minus x minus 6. So first thing is, what's a equal to? Anybody got a thought? 1. What's b equal to? Oh. Thank you. Negative 1. Remember, it's always looking like this. Ax squared plus bx plus c. It needs to be positive. So what would c be equal to? 6. So now, I want to figure out where the vertex of this thing is going to be. Now, it says identify the x-intercepts and all that other stuff, and that's fine. There is a method to my madness when we're going through doing this. If I can find where the vertex is at, it'll make life a lot easier when I try and do everything else. So, remember that was negative b over 2a. That's the number I want to look for. So, I'm going to write this thing down. I've got my negative. What is b? B is negative 1 over 2. What's a? 1. One of the biggest mistakes that people tend to do is they say, oh, there's a negative there, I don't need that other negative. Yes, you do. So this ends up going plus plus, and I end up with the value of 1 over 2. So what this is telling me is that somewhere over here where x is equal to a half is where it's going to be for the vertex. Don't quite know where it is yet. Now, one of the ways that I'm going to kind of help us out here is I'm going to count this out every other one. So this is going to be 1, 2, 3, 4. I'm going to count this up as 1, 2, 3, 4. So just every other one. Now, in order for me to deal with this, I need to put in a half and figure out where it's going to be, right? This number here has to go into this equation. So I'm going to have 1/2 squared minus a half minus 6. Now, does anybody really want to go through and do that math? So, calculator. So, reset. View detached hills. So, reset it. So I've reset it. I'm going to go to y. I'm going to put my equation. What's my equation? That's the x squared minus x minus 6. I've got that information in. Now, in this case, what I'm going to do is I'm just simply going to graph it out. I want to know where this half bit is. So, we hit the trace. What number do I want to put in for x? 0.5. Where we want to put it in. So if I do that, the calculator automatically goes through and calculates it out. So I now know exactly where this is going to be. I know that this thing is going to be at vertex is going to be at 0.5, comma, negative 6.25. So I know, let's see, half was right there, 1, 2, let's see, what did I say I was going down by? 1, 2, 3, 4, 5, and I like that, I ran out of room. Right about down there. Remember, in order to figure this out, you got to use trace. Now, it's supposed to identify the x and the y intercept. Y-intercept, easy. Why is it going to be easy? Because I know exactly where it's going to go through the y-axis. It goes through the y-axis right here at C. C is at negative 6. So that means it's going to have a point right down about here. Now, do you know what the shape of a parabola looks like? Kind of a U shape, right? Okay, so if this is a U shape, my vertex is down here, I've got another point on here. Do I know which way it's opening? I know it's opening up. I also know that if this is at 6.25 is right here, that's 0.25 away. If I go another 0.25 right about here, I am going to have another point. Why do I know this? Do I know what shape this thing has? I know it comes down and goes back up. Now, I've got 3 points very quickly. Very little calculating. Next thing. I want to find where these zeros are. The x-intercepts. Where does it go through the x-axis? Do you remember the command that we used before to find this? If I go to second, trace, I get a calc. Remember seeing these things? Second calc. What do I want to find here? 0. Do I see 0? I see 0. So I hit 0. Press enter. Now, we've talked about this before where it has the left bound and the right bound. Basically, we want to find where it's between. I know that it's somewhere in here, somewhere between these two. So I'm going to press the arrow key back. I'm going to put it above it because that's on the left side of it. Now it wants the right side, right? So I'm going to arrow key to the right. Press enter again. So somewhere in this gap, somewhere in between these things, is where the 0 is at. So I press enter, and it tells me the 0 was at negative 2. Oh, that's easy enough. So I now know that it goes through the x-axis here at negative 2, which puts it right about there. Now, the really nice thing about this is, if I didn't have decimals in here, it'd be a lot easier. But I know how far away this is. This is at negative 2.25. Negative 2.25. This way. Go that way. So it's going to be at approximately 2.5. Or 2.5. 0.5, yep. 1.5 plus that. 3. That's where the other 0 was going to be. Check that. Second, calc, 0. Which other 0 did I say it was? We got to go over here, right? So okay, around over here now. Enter. On the left side of it. Right side of it, more. Right there. Enter. What did I say that the number was supposed to be at? 3. Did I get 3? So I now know that I got 1, 2. Okay. Okay. There's my pro. Comes up, goes that way. Comes up, goes that way. Now, using the calculator is 10 times easier than actually trying to go through and do the calculations. Now the last thing that we have to do here is identify the domain range. Now remember, domain is what goes in, range is what comes out. Okay? Is there a number that I cannot put in here? No. So your domain, all reals. Put any number in I want. What's the range? Remember when I had the little stick dudes, you know, where would he have to go down to get around this thing? Well, he'd have to come all the way down here, correct? How far down is that? Negative 6.25. So the range for this is where y is greater than or equal to negative 6.25. The more that you do of these, the easier it will become. You'll see it a lot faster, but you've got to actually work on it. So, engineering. A bridge built over a stream can be modeled by the coordinate plane by this, where x represents ground level and units of the graph represent feet. Find the horizontal distance the bridge spans. Okay. So we got to build a bridge, right? Over a stream. That's the... I suppose this time of the year it'd be white, right? So I need to build a bridge across this thing, right? What I'm looking for is, as the bridge is going across, how far is this distance? Now it said that I could be modeling this on the coordinate plane by the function, where x represents ground level. So we're going to go and do this. Y is equal to, and we're going to put that equation in. So we'll clear that off. I'm going to put negative 0.25 x squared in, plus 16. Now, if I really don't understand where this thing is going to go, I can just simply hit graph. Okay, I see it come up, and I see it go down. Now, if this is supposed to be a bridge, do I care about the peak of it, where that's at right now? No. Really, the only thing that I'm concerned about is this coordinate right here and the coordinate over here. Now it looks like it's fairly symmetrical, right? It's on the same side of the x and y axis. I could check that out if I wanted to. I could do the, the negative b over 2a bit. But what's b in this case? If I wanted to find out this is negative b over 2a. What would b be equal to? Do you see an x there? I see an x squared, I see a 16, but I see no x. It's 0. It makes sense because it goes right up the middle. So what I want to do here is find out what, say, this coordinate is over here. Now, I could use the 0 thing, or I could take a look at this and say, what does it look like it is? How many marks over do you think it is? 1, 2, 3, 4, 5, 6, 7, 8. Looks like it's 8 over, right? So if I hit trace and I put in my 8, did I hit it? Yeah. Now, the thing is, if it's 8 from here over here, guess where this one's at? Negative 8. And it is. So I know that this here is at 8. I know this side here is at negative 8. So how far is it between it? 16. Because it's 8. Look at the center here. That's a distance of 8. That's a distance of 8. So the whole thing has to be 16 feet. It takes time. So, I'm going to give you a few minutes here, and I want you to go and put these two into standard form. Put them into standard form. All right, I'm going to do the first one. Now, the object of the game here is to make sure that you have it written in standard form. Well, that's y is equal to ax squared plus bx plus c. I got a question for you. It doesn't matter which side of the world the y is on. No. Doesn't matter at all. So if I've got 11 minus x squared is equal to y plus 7x, this is what I would do. Subtract 7x, subtract 7x. So I've got this written out in order as negative x squared minus 7x plus 11 is equal to y. Now, if you have it written out like this, that y is equal to negative x squared minus 7x plus y, is that the same thing? Yeah. You have to understand that the left side and the right side doesn't matter. They're equal. That's why we call it. Now, if you didn't do it that way, and you did it the other way, what it would look like is this. You would have subtracted 11, subtracted y. Doesn't matter where you put it, subtract y. And then you've got to add x squared, add x squared. So you got to do a lot of moving around here. So the 11s cancel out. Those cancel out, so I'm left with negative y is equal to x squared plus 7x minus 11. The problem is you're not done yet, because you want to know what y is equal to, not negative y. So all the signs change. Y is equal to negative x squared. Minus 7x plus 11. This is why it's the easiest thing that you can do is figure out where y is equal to, where y is positive, move everything to the other side. So that's what that one looks like. Now, next one. It's like this. Minus stays out in front. Remember, I got a squared here. So it looks like this, x minus 1 times x minus 1 minus 5. Foil this out. Negative is still out in front. X squared minus 1x minus 1x plus 1 minus 5. Like terms. Negative is still hiding out there. So that's x squared minus 2x plus 1 minus 5. Now I got to deal with that negative. So that negative goes here, here, and here. So what does that look like? Well, that looks like negative x squared plus 2x minus 1. Signs just changed. By the way, do I still got that minus 5 out there? Yeah. So when I add like terms, I'm going to end up with f of x is equal to negative x squared plus 2x minus 6. That's what that was. Yeah, I mean, it's a lot of writing, and that's just the way it is. There's no other way around it. So, yes, sir. Yep. Okay. Because otherwise, you got two constants sitting back here. They get combined together for the negative signs. Whenever you have things that are the same, you want to put them together. So, okay. Graph this. But, you want to see the easy way? Who wants the easy way? Okay. So you've got to graph this. The easy way is using the calculator, is it not? So, what do y equals? Clear it out and put the equation. But don't do not hit. Press your second key. Then hit graph. Now you need to graph this thing out. You got to draw it out. But where in the world is the vertex? Where does it start? These things have this wonderful thing called symmetry. What's on one side, you see on the other. Do you see any symmetry going on? I see 4, 0, negative 2, negative 2, 0, 4. So I know what this thing is going to look like. Okay. So, first one I got is at 0, 4. So if x is 0, y is 4. 1, 2, 3, 4. Okay. I know that at 1, it's 0. Goes right there. I know that if it's at 2, it's going to be at negative 2. Goes right there. I know that at 3, it's also negative 2. By the way, does that tell me where the vertex is, the bottom part of this thing? Should it be right between those two? So the next one here is going to be at 4, 0. 1, 2, 3, 4, 0 right there. Next one is 5, which is at 4. 1, 2, 3, 4 goes up there. Now 6 is at 10. Goes all the way up here. By the way, if I know that, do I know where 6 is on the other side? Would 6 be right about there? 1 over and up, 1 over and up. So, I've got this that I can draw it out, and I know where it's going to be and what it's going to look like. So if I hit the graph there, kind of close. Never said my drawing was any good, but when you are doing this, always use the graphing calculator. It's going a lot quicker and easier for you. So, if I take a look at this and I ask you to estimate, okay, where is this thing going through the vertex? Or not the coordinates of the vertex, but where is it going through the x-intercept? Where is it going through the y-intercept? So, give you, we're kind of running out of time here. Who thinks they know where the y-intercept is? It's the easiest one up there. Number's right there. 28. Absolutely correct. Y-intercept is 28. The y-intercept will always be the constant. The y-intercept will always be c. Okay. Now, I need the x-intercepts. Can anybody tell me what this x-intercept is? What's that one at? 1, 2, 3, 4. So that's 2, 4. So that's going to be at negative 4, comma 0. Okay. Do we know where that one's at? 1, 2, 3, 4, 5. I don't really know. Okay, I can't tell. This is where that negative b over 2a stuff kind of comes in handy. Now, I really don't care where the y is at. I just want to know what negative b over 2a is. So, my b is 11 over 2 times a. What's a? 1. So I get a negative 11 over 2. What's that? Isn't that negative 5.5? Does that look like it could be at negative 5.5? Okay. That's the vertex. So if I know that this is at 5.5 negative, that is at negative 4, do I know exactly where that is? Well, yeah, it's 1.5 beyond it. What is 1.5 beyond that? Well, that's negative 7. So that's going to be at negative 7, 0, which is what some of you figured it was going to be. Now, the last thing that I would have to do is figure out what this is going to be. Now, if I'm looking at this, I could do the math and plug it in there, but what does it look like it's at about? Because it does say estimate. So that's going to be 2, I'd say it's probably right around what? 2.125 or 2.25, something like that. So if you were to write it down as negative 5, oops, sorry, negative 5.5, comma, negative 2.25, would that be close? So, domain and range. When in doubt, graph it out. Yes, it was supposed to sound just something. So, y is equal to, clear it out, plug her in, negative x squared minus 4.5. Enter. Graph. The one thing that I need to know here is that I have to figure out where it's going through the axis. Okay, I need to know its maximum point. So, to do this, I am going to go second, calc, and I am going to go down here to say number 4. Calc is above the trace. Left side. Right side. Enter. Now, says kind of something weird here, right? I don't know quite what that is. I could also use this thing here to plug it in, but my b is going to be 0. So, what do I know about the range? Right here. Again, domain, all real. Range, y is going down, less than or equal to negative 4.5. And that would be that.